If we have two or more points in the plane, one of the questions we'd like to be able to answer about them is, how far apart are they? And we define the distance between them, which we'll write d for distance, a comma b, to be the length of the segment that connects them. Right, so we write the length of the segment as just the two letters next to each other. We write the distance as d of a comma b, and those are equal. They're always going to be the same value. We'll use those two notations interchangeably. Now, it's easy to find the length for horizontal and vertical segments. And let's see how. So I'm going to plot these 4 points. So I'll need axes. Let's see, my x's appear to go from -3 to 2. My y's go from -1 to 2. So let's see, something like this should work. We'll have point A is at -3, 2. Point B is at 1, 2. And to find the distance between them, we'll think about the segment that connects those. Point C is at 2, 2. Point D is at 2, -1. And to find the distance there, we'll think about the segment that connects those. Now, segment AB, right, its length, well, it's 1, 2, 3, 4 units long, which it looks like we could find by taking 1 minus -3. 1 minus -3. To find out how far it is to get from -3 up to 1, we take 1 minus -3, and then we don't move vertically at all. So we just want a horizontal distance. Segment CD, well, that's 1, 2, 3 units long. So the distance from C to D is 3. And it looks like we could find that by doing subtraction with the y-coordinates. 2 minus -1. To find out how far it is to get from -1 up to 2, we take 2 minus -1. And then there's no horizontal movement. And in fact, that gives us a method in general to find horizontal distances and vertical distances. If we have 2 points with the same x-coordinate, so those will be on a vertical line, same x-coordinate on a vertical line. To find the distance between them, well, we want to subtract the y-coordinates. But distances are always positive, and so that we don't need to fuss about what order we write those in, we'll just take the absolute value. Remember, reversing the order of subtraction just swaps the sign. So if we want to always subtract in the order that makes it positive, we can just subtract in whatever order we like and then take the absolute value. If we have 2 points with the same y-coordinate, notice same y-coordinate, then those are on the same horizontal line, and to find the distance we just subtract the x's. And again, we want to subtract in the order that gives us a positive number. So we'll just take the absolute value. Instead of being fussy about the order we subtract in, we can just subtract in any order and then take the absolute value. If our segment is not horizontal and it's not vertical, then we use the idea about right triangles that we talked about, and we use the Pythagorean theorem. So the Pythagorean theorem describes this property of right triangles, which is, if we have a right triangle whose legs have length A and B, and whose hypotenuse has length C, so our triangle is going to look something like this. Right angle, A, B, C. It doesn't matter which of A or B is longer. That doesn't matter. Then, if we take the leg lengths and square them and add the results together, that's the same as squaring the length of the hypotenuse. So that's the Pythagorean theorem. We've seen this before. We'll see it again. But in this case, we're going to use it in order to find the distance between 2 points in the plane. So for this example, we're going to plot the points. In general, we don't have to plot the points. We can just use the coordinates. But so we can see what we're doing, we're going to plot the points here. So we want to plot the points -3, -2, and 1, 1. So my x values are going to go from -3 to 1. My y values are going to go from -2 to 1. I think I can draw my axes something like this. And then I have the points A at -3, -2, and B at 1, 1. And I connect them with a line segment like this. And then, to use the Pythagorean theorem, I need a right triangle that has this hypotenuse. So I'm going to drop a point down here. The legs are horizontal and vertical lines that I already know how to find. Right? A, B. And then ultimately my goal is to find C. So A, that's the distance from this unnamed point to B. My unnamed point is at 1, -2. So to get from 1, -2 up to 1, 1, I'll need to take 1 minus -2 and then take the absolute value of that. So a squared, now this is neat. When I square it, I no longer need the absolute value, because when I square it, I get a positive result regardless. So I don't need the absolute value anymore if I know I'm going to square it. B, well, I'm going from -3, -2 to 1, -2. So I'll have -3 minus 1, take the absolute value. I'm not going to fuss about what order I put those in, because I'm taking the absolute value. Or when I put it into the Pythagorean theorem, I'm squaring it. It doesn't matter what order I put the values in here, as long as I keep my x's together and my y's together. And notice, the x value of this point is an x value I already had. The y value of this point is a y value I already had. For A, I'm just subtracting the y's. For B, I'm just subtracting the x's. So then my c squared, right, a squared plus b squared is c squared. My c squared is 1 minus -2 squared plus -3 minus 1 squared. And working out that arithmetic, that's 9 plus 16 is 25. Right? C squared is 25. We know that C is going to be positive because it's a distance. So c is just the positive square root of 25 is 5. The distance from A to B in this diagram is 5. Okay, so in general, we can do that with any 2 points. And in fact, even if we have a horizontal or a vertical line segment, that'll actually work just fine. If our line segment happens to be horizontal or vertical, one of A or B will happen to be 0. Right? If my x's are the same, I'll get 0 when I subtract my x's. If my y's are the same, I'll get 0 when I subtract my y's. This gives us a formula for how to find the distance between any 2 points. So we take the difference in the x's and square it, difference in the y's and square it. Right, that gives us the square of the distance. So to find the actual distance, we take the square root. And ultimately, you will want to know this formula off the top of your head, but it's much, much easier to remember how this formula goes together, to remember where each value goes, if you keep in mind that what you're using is the Pythagorean theorem.